Hello, this is Sujit. Welcome to Physics 2020. So today we are going to discuss a very important topic, that is graphical analysis of motion. So in this chapter so far we have discussed what is distance, what is displacement, speed, velocity, acceleration, and the kinematic equations to deal with these quantities, the motion under gravity, and in the last session we have discussed the problems related to the motion under gravity. So in this section we are going to discuss the graphical analysis of motion. So the quantities, that is distance, displacement, speed, velocity, acceleration, etc., how to represent these quantities graphically and to study the variation of these quantities. Suppose if displacement time graph is given, how to find the velocity from that graph. If a velocity time graph is given, how to find the acceleration from that graph. Okay, if a velocity time graph is given, how to find the displacement, that is using the area under the curve. So these are the things we are going to study. So and the relation between these graphs, that is suppose if a displacement time graph is given, how to draw an equivalent velocity time graph, how to draw a equivalent acceleration time graph. Okay, so another very important significance of this graphical analysis of motion is, so the most of the numericals we have solved earlier can be solved using this graphical method, in a very easy manner. So that is the another very important that is significance of this graphical analysis of motion. Okay, so in this video it is full and fully the conceptual video of, that is, graphs. Okay, in the coming session we will solve the problems using these graphs. Okay, we start with, that is, graphical analysis of motion. So in this session we are going to discuss about the three graphs. One, displacement time graph. Okay. Two, velocity time graph. Third one, acceleration time graph. Okay, so these are the three graphs we are going to discuss in this session. So consider a graph. So this is y-axis and this is x-axis. Okay, so consider a curve. Okay, so I am considering 2 points, this curve. So the x coordinate value I am taking as x1, so the corresponding y coordinate value, that is y1. Okay, so x2 is y2. Okay, so when we study about these graphs or graphical analysis of motion, two things we have to consider. One, that is slope of the curve. Two, area under the curve. Slope of the curve and area under the curve. What is slope of the curve? Slope of the curve at a particular point, is nothing but the slope of the tangent at that point. What? Slope of the tangent. slope of the tangent. ठीक है, slope of the tangent, slope of the tangent at that point. So suppose if you want to find the slope of the curve, slope of the curve at the point P. So I am taking this point as P and this point as Q. Okay, slope of the tangent at the point P means, so draw a tangent. Okay, draw a tangent. Okay, so this tangent makes an angle theta with the horizontal x-axis. Okay, so the slope of the tangent we know that, so is equal to tan theta, is equal to tan theta. So theta is the angle made by the tangent with the horizontal x-axis, horizontal x-axis. My dear students, if you want to thoroughly understand this topic, that is what is function, how to draw a curve for the function, okay, what is slope of the curve, what is positive slope, what is negative slope, what is the maxima of a function, and what is the minima of a function. So such things if you want to clearly understand, means in Physics 2020 there is a video, that is there is a playlist called Mathematical Support for Physics. So in that playlist I have uploaded one video, that is differentiation part 1. So in that video I have discussed these things in very detail. Okay, so if you want to know about these things in very detailed manner, means you can watch that video. So for the time being I will say the essential things only. Okay, so anyway, the slope of the tangent at the point P is nothing but the slope of the curve at this point P is nothing but the slope of the tangent drawn through that point. So which makes an angle theta with the horizontal x-axis. So that is equal to tan theta. So suppose in the similar way, suppose if you want to draw find the slope of the curve at the point Q. So draw a tangent through, okay, Q. So it makes an angle, this is theta 1, this is theta 2, okay, theta 2. Okay, so clear, that is slope of the curve. Slope of the curve at that point is nothing but the slope of the tangent drawn through the point. Okay, drawn through the point. So that is slope of the tangent is nothing but tan theta. Theta is the angle made by the tangent with the horizontal x-axis. So next very important thing, that is what is positive slope? What is positive slope and what is negative slope? What is positive slope and what is negative slope? So before that, so I will write the tan values of the standard angles. So theta, tan theta, 0, okay, 30, 45, 60, 90, 120, 135, 150 and 180. Tan 0, 0, tan 30, 1 by root 3 tan 45, 1, root 3 tan 90, infinity, minus root 3, minus 1, minus 1 by root 3 tan 80, 0. Okay. So what is positive slope and what is negative slope? If the angle made by the tangent, if the angle made by the tangent with the horizontal x-axis is below 90 degree. So less than 90 degree means it is positive slope. You look at the value, that is the values less than the angle values, standard angle values less than 90 degree means it is positive values only. Okay, positive values. So that is called positive slope. If the tangent, that is if the angle made by the tangent with the horizontal x-axis is greater than, that is the angle value greater than 90 degree means it is negative slope. So or otherwise the tangent drawn for the curve in the increasing portion of the curve. So increasing portion of the curve. So this is the when you consider this curve, so this is the increasing portion of the curve. So the curve is increasing. So at this point it reaches the maximum and this curve decreasing. In this portion the curve starts to decrease. So in the increasing portion I have drawn two tangents. So it is perpendicular means 90 degree. So angle is always measured in the anti-clockwise direction. So in this position, when from this point to this point, anti-clockwise direction, the angle increases. So this angle, that is 0 degree. So when it starts going anti-clockwise, that is angle increases. Okay, so the increasing portion I have drawn two tangents. This makes an angle theta that is less than 90 degree. So that is theta less than 90 degree. Okay, so that is positive slope. So if you draw a tangent at the decreasing portion of the curve, so increasing portion and a decreasing portion of the curve. Suppose I am drawing, this is decreasing portion of the curve. So at this point I am drawing one tangent. Okay, so if you find the angle means, so this is greater than 90 degree. So the angle value is greater than 90 degrees, that is negative values only. So theta is negative, that is called negative slope. Okay, negative slope. Clear? So positive slope and negative slope. Positive slope is if the angle made by the tangent with the horizontal x-axis is less than 90 degree means it is called positive slope. Or otherwise we can say that if the tangent at the increasing portion of the curve is, that is positive slope. Okay, so the negative slope is the angle of the, that is the angle made by the tangent with the horizontal x-axis is greater than 90 degree, then it is called negative slope. Or decreasing portion of the curve we get negative slope. Okay, then area under the curve. Next is area under the curve. Suppose if you want to find the area under the curve in the between the points P and Q. So this is the area under the curve. Okay, so area under the curve is the continuous product of x and y. Okay, area under the curve. Area under the curve is equal to, that is continuous product of x and y. Suppose this area consists of n number of strips. Okay, this area, that is this area consists of n number of strips. Each have the thickness dx and the corresponding y values are y1, y2, etc. Okay, suppose if this area is divided into n number of small strips, each strips having the thickness dx and the corresponding y values are y1, y2, etc. Then the area under the curve we can write, that is y1 into dx plus y2 into dx plus y3 into dx plus etc. plus yn into dx. That is the area under curve. That is nothing, this is nothing but integration of, integration of, that is x1 to x2, that is y dx, y dx. So this is the area under the curve. So clear? So graph, that is slope of the curve, then positive slope and negative slope, and area under the curve. Okay. So the next is displacement time graph. Displacement time graph. So consider a displacement time graph. So this is displacement time. Okay. So this is a displacement time graph, so which makes an angle theta. Okay, theta. So slope of this displacement time graph, slope is equal to, slope of this displacement time graph is equal to, so we know that is tan theta. Okay, tan theta. So tan theta is equal to perpendicular by base, that is y2 minus y1 divided by x2 minus x1. Okay, perpendicular by base. Tan theta formula, that is perpendicular by base. So y2 minus y1 divided by x2 minus s1. So in the y axis displacement, so s2 minus s1. In the x axis time, that is t2 minus t1. Okay, t2 minus t1. So that's equal to change in displacement, that is delta s by time, change in time, that is delta t. So delta s, change in displacement divided by change in time. So that's equal to velocity. Velocity. So from this what we can understand, the slope of the displacement time graph gives the velocity of the motion. So slope of the velocity time graphs gives the velocity of the motion. Clear? Okay, that is very important. Then, so we are going to study about the displacement time graph. So displacement time graph, the slope of the displacement time graph gives the velocity of the motion. Okay, velocity of the motion. So we are going to study different displacement time graph. Case 1, body is at rest. Body is at rest. So how to draw the displacement time graph? Displacement time. Okay, displacement time. So at a time t1, so the body is at a particular position. Okay, t1. At the time t2, the body is at the same position because body is at rest. The position does not change. Okay, so t2. Okay, so this is the displacement time graph for body is at rest. That is, at the time t1, the body is at a particular position. At the time t2 also, the body is at the same position because the body doesn't change. The position doesn't change. That is, body is at rest. Okay, so this is the displacement time graph for, that is, body is at rest. So what is velocity? So velocity is nothing but the slope of the displacement time graph. So what is the slope of this curve? The graph is parallel to the x-axis. Slope is equal to 0. Slope is equal to 0. So tan theta is equal to 0. So velocity is equal to 0. Velocity is equal to 0. Okay? Velocity is equal to 0. So the body is at rest means body is not changing from the position. So velocity is 0. Okay? Velocity is equal to. So what about the acceleration? Acceleration is also 0. Okay, that is case 1. Then case 2, it is uniform motion. Case 2, uniform motion. Uniform motion means velocity is equal to constant. Velocity is equal to constant. Uniform motion, velocity is equal to. So in this case, we have two cases. So velocity may be positive or velocity may be negative. So velocity constant means velocity may be positive or velocity may be negative. Okay. So first case, velocity is equal to constant and positive. So displacement time graph. Okay, displacement time graph. So the slope of the displacement time graph gives the velocity. Okay, slope. So this graph makes an angle theta. So the slope of this, so this is a displacement time graph. So the slope of the displacement time graph gives the velocity. So it makes an angle, the velocity displacement time graph makes an angle theta. So velocity is equal to the slope of the displacement time graph, that is slope is equal to tan theta is equal to velocity. Am I right? Velocity. So the displacement, the slope of the displacement time graph, that is equal to tan theta, that is the velocity of the motion. So that theta, it makes an angle theta. So theta less than 90 degree. Theta less than 90 degree. So the less than 90 degree means tan values are positive. Okay, positive. So slope is equal to, therefore angle less than 90 degree, that is theta less than 90 degree. So tan theta positive. So therefore slope positive. Therefore velocity positive. Okay, velocity positive. Clear? So the slope of the displacement time graph gives the velocity. So here the angle made by the curve, that is theta. So less than 90 degree. Less than 90 degree means tan values are positive. Tan values positive means slope positive. So slope gives the velocity. So therefore velocity positive. Kadam? Okay. So this is positive. Then velocity is equal to constant. Velocity is equal to constant. So at each and every point, if you find the slope, it gives the same slope. That is, slope is constant. So at every point, that is, if you find the here also theta, here also theta. Okay, at each and every point, if you find the slope of the curve, theta is not varying, slope is not varying, slope is constant. Slope is constant means velocity is equal to constant. Okay, so here 30 degree means everywhere that is 30 degree. Okay, 30 degree. Or 60 degree means everywhere 60 degree. So tan 60 always gives the same value. So that is slope constant. Slope gives the velocity. So velocity constant. So velocity constant, positive satisfied. Okay, so this is the displacement time graph for velocity constant and velocity constant and positive. Clear? Okay. Then next case, velocity constant. Okay, velocity constant but negative. Velocity constant but negative. So what is the displacement time graph? Displacement time graph. Yes, displacement time graph. So this is the graph, displacement time, velocity, displacement time graph. So what is the slope of this curve? Yes, theta. So this is 90 degree. So when it goes like this, that is 90 greater than 90 degree. Okay, greater than 90 degree. So slope, that is 0, that is horizontal 0. So increasing, so it comes 90 degree. So gives 90 greater than 90. So the theta values are greater than 90 degree, that is equal to negative. Okay, negative. So here theta greater than 90 degree. Okay, theta greater than 90 degree. So tan theta negative, slope negative, velocity, slope negative means velocity negative. Okay, then constant. Here also, if you find the slope at each and every point of this curve, okay, so theta so at each and every point the slope is constant. Okay, slope is constant. So therefore velocity constant. Clear? So velocity is equal to positive. So uniform motion. So this is the displacement time graph for uniform motion. Okay, uniform motion. So velocity, uniform motion means velocity constant. Okay, velocity constant. So velocity constant means it may be positive or negative. Okay, velocity positive or negative. So positive means, positive constant means displacement time graph. Negative constant means, so displacement time, just like this. Clear? So in the case of uniform motion, so what about the acceleration? So uniform motion, so the displacement time graph, displacement, okay, displacement time graph. Okay, so velocity positive, constant positive, positive and negative. Okay, constant positive and negative. So what about the acceleration in two cases? Acceleration is equal to, yes, so acceleration is equal to dv by dt. So here uniform motion means velocity is equal to constant. Velocity is equal to constant. So in both the cases acceleration is equal to 0. Here also acceleration is equal to 0. Here also acceleration equal to 0 because it is a uniform motion. So velocity is equal to constant. So therefore acceleration is equal to dv by dt. So therefore acceleration is equal to 0. Okay. So the next case, non-uniform motion. non-uniform motion. Non-uniform motion. So in this case, case 3, this is case 3, non-uniform motion. So in these 4 subcases, A, velocity positive increasing, velocity positive decreasing, okay. C, velocity negative increasing, velocity negative decreasing. So these are the 4 cases we have to discuss in non-uniform motion. So we have to study, or we have to analyze the displacement time graph for these 4 cases. Okay. So first case, velocity positive and increasing. So this is a displacement time graph. Displacement time graph. Okay. Time graph. So point at a time t1, time t2, okay, t2 greater than t1, okay. 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 So from this graph, what are the conclusions we can make? 1, concave upwards. The graph is concave upwards. Okay. 2, theta less than 90 degree. So if you observe the slope, that is, slope is less than 90 degree. So less than 90 degree means tan values positive. Okay, theta less than 90 degree, that is tan theta positive. Tan theta positive means slope positive. Okay, slope positive. Slope positive means velocity positive. So here velocity first, A, velocity positive. Okay, velocity positive. Third point, as time increases, okay, time increases. So the slope at the tangent, at the slope at the point for the time t1 and t2, you observe the slope for time t1 and t2. The slope for time t2 is greater than the slope of the tangent at t1. So okay, as time increases, slope, okay, you look at the graph, that is slope increases. Time increases means slope also, that is the slope of the tangent at t1 is less than the slope of the tangent at t2. So at time increases, slope increases. Slope increases. So in tan theta value, that is in positive side, as the angle value increases, tan theta value also increases. Okay, tan theta increases. Tan theta increases. Tan theta increases means velocity increases. Velocity increases. Okay, so tan theta velocity positive, increasing. Okay, so here what about the acceleration? In this case, acceleration. So as velocity increases, acceleration also increases, because velocity increases means it is a accelerated motion. It is a accelerated motion. Okay, it is a accelerated motion. So what is the direction of the acceleration? So acceleration is also in the direction of the velocity in this case. Okay, so it is an acceleration. Velocity increases means acceleration is also in the direction of the velocity. So acceleration positive. Acceleration positive. Okay, so velocity increasing. So it is an accelerated motion. Acceleration is also in the direction of the velocity. So acceleration positive. Clear? Okay. Then the next case. Next, velocity positive decreasing. Velocity positive decreasing. So it is the displacement time graph. Displacement time graph. So this is the curve for, so this point T1, T2. Theta 1, theta 2. Okay. So what are the conclusions we can make from this graph? 1. Concave downwards. Concave downwards. 2. Theta, here also theta less than 90 degree. Okay, less than 90 degree. So theta less than 90. Okay, theta less than 90. That is tan theta positive. Tan theta positive means slope positive. Slope positive means velocity positive. Velocity positive. Second case, velocity. Yes, we got velocity positive. Okay, velocity positive. Third point, as time increases, okay, time increases. So if you look at the graph, time increases, the slope of the tangent at T1 is greater than the slope of the tangent at T2. As time increases, slope decreases. Slope decreases. Okay? Slope decreases means tan theta, okay, angle value decreases means in the positive side. Decreases means tan theta value decreases. So tan theta decreases. Tan theta decreases means velocity decreases. Okay, velocity decreases. So velocity positive and decreasing. So what about the acceleration here? Acceleration. So velocity decreases. Velocity decreases means it is a decelerated motion. Okay, decelerated motion or retarded motion. Retarded motion. Okay, retarded motion. So retarded motion means velocity in this direction, acceleration in this direction. So here velocity is positive, so acceleration is opposite to velocity. So acceleration is negative. Okay, acceleration negative. acceleration negative. So velocity, so decelerated motion, velocity in this direction, acceleration in this direction. Here velocity is positive, so acceleration should be negative. Okay, should be negative. Okay. Then the third case, next case, velocity negative increasing. Displacement time graph, displacement time. Okay, displacement time. T1, T2. So this is theta 2. So what are the conclusions we can make? One, concave upwards, sorry, concave downwards. Concave downwards. 2. So the theta values greater than 90 degree. Okay, theta greater than 90 degree. So tan theta value, so greater than 90 degree means tan theta negative. Tan theta negative. Tan theta negative means slope negative. Slope negative means velocity negative. So velocity C, velocity negative. Third point, as time increases, slope decreases. So look at the graph. So the slope of the tangent at T1, okay, T1 is greater than the slope of the tangent at T2. So this line is more steeper, okay, more steeper. So slope increases. So slope decreases. So in the negative side, if the negative value, the angle value decreases means tan theta value increases. Okay, slope in the negative side here. Okay, so the angle value decreases means tan theta value increases. So slope decreases, therefore tan theta increases. So therefore velocity increases. Okay, velocity increases. So that is negative increasing. So as time increases, slope decreases. Okay, slope decreases. So slope decreases means the negative side. Okay, slope decreases means tan theta value increases. Okay, tan theta value increases. Tan theta value increases means velocity increases. Okay, velocity increases. So therefore velocity negative increasing. Okay, so what about the acceleration here? So in the negative side velocity is increasing. So velocity is increasing means it is a accelerated motion. It is a accelerated motion. So what is the direction of the acceleration? Acceleration is also in this direction of the velocity. Okay, velocity. So acceleration negative. Okay, acceleration negative. Okay. So velocity negative and increasing. Okay, increasing. Okay, the last case, velocity negative decreasing. So displacement time graph. Always like this. Okay. T1. T2. Curl is like this. So what are the conclusions we can make? One, that is concave upwards. Two, theta greater than 90. So the angle made by the tangent with the horizontal x-axis. Okay, so theta greater than 90. Tan theta negative. Slope negative. Velocity negative. So D, velocity negative. Third point, as time increases, okay, time increases. So the slope of the tangent at a time t1 is less than the slope of the tangent at t2, or otherwise we can say slope of the tangent at t2 is greater than the slope of the tangent at t1. As time increases, slope increases. So in negative side, if the slope increases means that is greater than 90 degree, If the slope increases means tan theta value decreases. Okay, slope increases, tan theta decreases. Tan theta decreases means velocity tan theta decreases, velocity decreases. Okay, velocity decreases. So negative decreasing. Okay, negative decreasing. So what about the acceleration here? Acceleration. So velocity decreases means it is a decelerated motion. So retarded motion. Okay, velocity negative, retardation means in this direction. So acceleration in this direction. Velocity is negative. It is a retarded motion. So acceleration is opposite to the direction of the velocity. So velocity negative, acceleration positive. Acceleration positive. Kadam. Acceleration positive. So these are the 4 cases. So the curves, that is curves shape is very important. So velocity positive increasing, velocity positive decreasing. Okay, velocity negative increasing, velocity and negative decreasing. Okay, decreasing. Quick recap, that is a quick glance of these 4 graphs, that is displacement time graph, displacement time, displacement time, displacement time, displacement time. So the first curve is second curve, third curve, fourth curve. Nice. Here velocity positive increasing, acceleration positive. Okay, acceleration positive. Velocity positive decreasing, velocity positive decreasing, acceleration negative. Okay, velocity negative increasing, acceleration negative, velocity negative decreasing, acceleration positive, acceleration positive. Okay, clear? So the next is velocity time graph. So far we have discussed a displacement time graph. So velocity time graph. Okay, velocity time graph. So consider a velocity time graph. Velocity time. Okay. So the graph makes an angle theta with the x-axis. Okay, so slope of this curve, slope is equal to tan theta is equal to y2 minus y1, that is perpendicular by base, that is x2 minus x1. So that's equal to in y-axis, that is velocity v2 minus v1, t2 minus t1. So that's equal to change in velocity, that is delta v, change in time, that is delta t. So change in velocity divided by change in time, change in velocity by change in time, so that is acceleration. So that's equal to acceleration. So the velocity, the slope of the velocity time graph. Slope of the velocity time graph gives the acceleration. So slope of the displacement time graph gives the velocity. So slope of the velocity time graph gives the acceleration. Okay, acceleration. So case 1. Case 1, uniform motion. Uniform motion. So velocity time graph. So at a time t1, it has a velocity. Okay. T1. T2, it has the same velocity. Okay, that is uniform motion. So T1, so velocity is constant. Uniform motion means velocity is equal to velocity constant. So at a time T1, it has a velocity, T2 has the same velocity. So this is the graph. So what about the acceleration? Acceleration is the slope of the velocity time graph. What is the slope of this curve? That is, slope is equal to 0. Tan theta is equal to 0. Therefore, acceleration is equal to 0. So, acceleration is equal to dv by dt. So, velocity constant. So, acceleration is equal to 0. Okay. So, then non-uniform motion. Case 2, non-uniform motion. Non-uniform motion. Non-uniform motion means velocity increasing or velocity decreasing. Okay, decreasing. Okay. So first velocity time graph. So as time increases, velocity increases. Okay, velocity increases. So what is the theta? So acceleration is nothing but the slope of the velocity time graph is acceleration, gives the acceleration. So theta less than, here theta less than 90 degree. So tan theta positive, slope positive. So acceleration positive. Acceleration positive. Okay, acceleration positive. So, so if you find the slope at each and every point of this curve, that is, we can see that slope is also constant. Slope is also constant. Okay, so therefore, acceleration is equal to acceleration constant. Okay, so it is an accelerated motion. Okay, accelerated motion, that is constant acceleration. Constant acceleration. Okay. So then if the velocity decreasing, as time increases, so consider the velocity time graph. Okay, velocity time graph. As time increases, velocity decreases. Okay, velocity decreases. Velocity decreases. Velocity decreases. So theta. So theta greater than 90. Okay, theta greater than 90. So tan theta negative, slope negative. slope negative. The slope of the velocity time graph gives the acceleration. So acceleration negative. Acceleration negative. Okay, negative. So acceleration negative means it is retardation. Okay, retardation. Okay, retardation. So if you find the slope at each and every point, so okay, so theta. Okay, so slope is constant, so acceleration is also constant. So constant retardation. Okay, constant retardation. Okay, then consider the velocity time graph. Velocity time graph. Horizontal straight line, that is velocity is constant. Okay, velocity is constant. T1, T2. Okay, so A, B, C, D. Okay, so this is a velocity time graph. So this is the time T1 and T2. So we have to find the area under the VT graph. Area under the VT graph between the time T1 and T2. So that's equal to area of the, it is nothing but area of the rectangle. Okay, area of the rectangle ABCD. Area of the rectangle ABCD. Clear? Area of the rectangle ABCD. So that's equal to area of the rectangle length into breadth. Okay, length into breadth. That is AC into, that is CD. Length into breadth. AC into CD. So what is AC? So that is velocity. Okay, so what is CD? That is T2 minus T1. So that's equal to V into velocity V, that is T2 minus T1, that is time. That's equal to velocity into time. Okay, velocity into time. So velocity, so we know the relation, that is velocity is equal to displacement by time. So velocity into time is equal to displacement. Okay, displacement. That is very, very important. So the area under the velocity time graph gives the displacement. Okay, displacement. So very, very important. Area under the velocity time graph gives the displacement. Okay. So slope of ST curve. ST curve. What? Velocity. Slope of VT curve. Acceleration. Area under VT curve, that is displacement. Okay, so with this, this session is over. That is the conceptual session of graphical analysis of motion. So in the coming sections, coming 2 sections, we will discuss the problems related to the graphical analysis of motion. Okay, very important topic for Jeemains as well as Neet exam also. Very important topic, that is graphical analysis of motion. So study well and study all the concepts of these graphs. We will, in the coming sessions, we will discuss the problems. Okay, stay tuned. Bye.